Hello everyone, I am Kritika Tang from 6th semester Bhaskara. Today I am going to be presenting on the topic Planning and Modeling Principles, that is from the subject Software Engineering and Project Management. So let's get into it. So let's discuss the importance of planning principle and how they guide the creation of effective project plans. The role of modeling principle and how they facilitate a deeper understanding and precise representation of a software requirement and design. And then we will discuss the integration of planning and modeling principle, that how these principles work together to streamline the software development process. Coming to the planning principles, the communication activity helps you define your overall goals and objectives, like subject, of course, to change as they of course change as time passes. However, to understand these goals and objectives is not the same as defining a plan for getting there. The planning activity encompasses a set of management and technical practices that enable the software team to define a roadmap as it travels towards its strategic goal and tactics and objectives. There are total 10 planning principles. Let us discuss them one by one. The first principle states that understand the scope of the project. It's impossible to use a roadmap. If you don't know where you're going, scope provides the software team with a destination. Principle number 2, involve stakeholders in the planning activity. Stakeholders define priority and establish project constraints. To accommodate these realities, software engineer must often negotiate the order of delivery, timelines, and other project related issues. Principle number 3, recognize that planning is iterative. A project plan is never engraved in stone. As work begins, it is very likely that things will change. As a consequence, the plan must be adjusted to accommodate these changes. In addition, iterative incremental process dictates replanning after the delivery of each software increment based on feedback received from the users. Principle number 4, estimate based on what you know. The intent of estimation is to provide an indication of effort, cost, and task duration based on the team's current understanding of the work to be done. If information is vague or unreliable, estimate can be equally unreliable. Principle number 5, consider risk as you define plan. If you have identified risks that have higher impacts and higher probabilities, contingency planning is necessary. Principle number 6, be realistic. People don't work 100% of every day. Noise always enters into human communication. Omissions and ambiguity are facts of life. Change will occur. Even the best software engineers make mistakes. These and other realities should be considered as a project plan is established. Principle number 7, adjust granularity as you define the plan. Granularity refers to the level of detail that is introduced as a project plan is developed. A high granularity project plan defines significant work detail that is planned over relatively short time increments. Activities that won't occur for many months do not require high granularity. Principle number 8, define how you intend to ensure quality. The plan should identify how the software team intends to ensure quality. If pair programming is used during construction, it should be explicitly defined within the plan. Principle number 9, describe how you intend to accommodate change. Even the best planning can be obliterated by uncontrolled change. You should identify how changes are to be accommodated as software engineering work proceeds. Principle number 10, track the plan frequently and make adjustments as required. Software projects fall behind schedule one day at a time. Therefore, it must make sense to track progress on daily basis, looking for problem area and situations where work schedule does not conform to actual work conducted. Modeling principles. We create model to gain a better understanding of the actual entity built. However, when the entity to be built is a software, our model must take a different form. It must be capable of representing the information that the software transforms, the architecture and the function that enables the transformation to occur, the feature that user desires, and the behavior of the system as the transformation takes place. Software must accomplish this objective at different level of abstraction. First, the description of the software from customer's point of view, and later the representation of the software at more technical level. Modeling principles. Principle number one. The primary goal of the software team is to build software, not create models. Agility means getting software to the customer is the fastest possible time. Models that make this happen are worth creating, but the models that slow down the process or provide less insight should be avoided. Principle number two. Travel light. Don't create models you don't need. Every model that is created must be kept up to date as change occurs. Most importantly, every new model takes time that might otherwise be spent on construction. Therefore, create only those models that make it easier and faster to construct the software. Principle number three. Strive to produce the smallest models that will describe the problem on the software. Don't overbuild the software. By keeping the model system simple, the resultant software will also be simple. Principle number four. Build models in a way that will make them amendable to changes. Assume that this model will change, but in making this assumption, don't be sloppy. Principle number five. Be able to state an explicit purpose for each model that is created. Each time you create a model, ask yourself why you're doing so. If you can't provide a solid justification for the existence of the model, don't spend time on it. Principle number six. Adapt the models you develop so that the system at hand. It may be necessary to adapt model notation or rules to the application that requires a different modeling technique than real-time embedded system that controls an automobile engine. Principle number seven. Try to build useful models, but forget about building perfect models. When building requirement design models, a software engineering reaches a point of diminishing return. That is, the effort required to make models absolutely completely and internally consistent is not worth the benefits of these properties. Principle number eight. Don't become dogmatic about the syntax of the model. If it communicates context successfully, representation is secondary. Principle number nine. If your instincts tell you a model isn't right, even though it seems okay on paper, you should have reason to be concerned. If you are an experienced software engineer, trust your instincts. Principle number 10. Get feedback as soon as you can. Every model should be reviewed by members of the software team. The intent of this review is to provide feedback that can be used to correct modeling mistakes, change misinterpretation, and add features or functions that are inadvertently omitted. Planning versus modeling principles. Planning principles provide guidelines for constructing the best map for the journey to a complete product or system. Plan may be designed solely for a single software increment, or it may be defined for the entire project. Regardless, it must be addressed what will be done, who will do it, and when the work will be completed. Modeling encompasses both analysis and design, describing the representation of the software that progressively becomes more detailed. The intent of the model is to solidify understanding of the work to be done and to provide technical guidelines to those who will implement the software. Modeling principles serve as a foundation of the model and notation that are used to create representation of the software. Advantages of planning and modeling principles. The first advantage is improved clarity and focus. Agile teams' objectives and resources provide visual representation for better understanding. The second is better risk management. Identifies potential risk and mitigates strategies, stimulates scenarios to anticipate issues. Third is enhanced decision making. It facilitates decision making with clear options, provide data driven insights and forecast. The next is resource optimization, ensures effective resource allocation, evaluates impact of different resource users. Last is improved communication, create shared understanding among stakeholders, simplifies complex information through models. The disadvantages of planning and modeling principles are time and effect. It is a time and effort intensive process. Potential for over planning. There is a potential for over planning. Risk of assumptions, cost implications, complex and it is complex and requires maintenance. It depends on quality of data. Integration of planning and modeling, streamlining the software development process. Aligning of goal and requirement. Planning, set clear project goals and requirement. Modeling, provide detailed representation, ensuring shared understanding. Efficient resource allocation. Planning allocates time, persons, and budget. Modeling identify technical requirements for precise allocation. Risk mitigation. Planning identify risks, develop mitigation strategies. Modeling detects flaws early, allow proactive. Improved communication and collaboration. Planning define roles, responsibilities, and timelines. Modeling facilitates discussion with visual detailed representation. Quality assurance. Planning establish quality standards and benchmark. Modeling ensures adherence to standards through iterative design. Flexibility and adaptability. Modeling structured yet adjustable approach. Modeling supports iterative development and adaptability. Enhanced decision making. Planning provides a statistic decision making framework. Modeling offers insights for data driven decisions and prioritization. Let's take an example for developing a new feature of an e commerce platform, a product recommendation system. Planning and modeling principles are crucial to ensure that the project is well organized and meets the desired objectives. Planning phase. It defines the objective and scope. The goal is to develop a recommendation system that suggests products to user based on the browsing history and purchase history. The scope. The system will analyze user behavior, preferences, and integrate with existing e-commerce platform to provide personal recommendations. Identify stakeholders. Internal stakeholders can be product managers, data scientists, software engineers, etc. External stakeholders can be end users of the e-commerce platform. Gathering requirements. Functional requirements. The system should recommend products based on user behavior, purchase history, and product popularity. It should also support real-time recommendation. Non-functional requirements. System must handle high traffic, be scalable, provide recommendation quickly within few seconds. Define success criteria. Accuracy of recommendation. Measure how relevant the recommendation are to users. User engagement. Track metrics such as click-through rates and conversion rates for recommended products. Develop a project plan. Timeline. Establish a milestone and deadline for each phase of development. Resource. Allocate team members, tools, and technologies needed for products. Budget. Estimate the cost of deployment, including the personnel and software and hardware. Modeling phase. We will design the architecture, system architecture, outline the overall structure of the recommendation system, including data sources, layers, integration points with the e-commerce platform, data flow. Determine how the data will flow through the system from user interaction to the recommendation generation. Choose the recommending algorithm. Collaborative filtering. Recommend the products based on the behavior of similar users. Content based filtering. Recommend the products similar to the ones user has already shown interest in. Hybrid method. Combine both the above methods. Data modeling. User profile. Create data models to represent user preferences, browsing history, and purchase history. Product profiles. Develop models for product attribute categories and user rating. Develop and test prototype. Prototype development. Build a prototype of the recommendation to test its functionality and performance. Testing. Evaluate the prototype using the test data and user feedback to refine the system and improve recommendation. Iterate and improve. Feedback loop. Gather feedback from stakeholders and users to identify area for improvement. Refinement. Update the recommendation algorithm and system components based on feedback and performance matrices. Implementation and deployment. Deployment plan. Prepare for the deployment of the recommended system to the production employment, including the trailing and system integration. Monitoring. Set up monitoring to track the performance of the system and make adjustment as. In this example, the planning phase involves defining the project goals, gathering requirements, and developing a detailed plan, while the modeling phase focuses on designing the system architecture, choosing algorithm, and creating the data models. Proper planning and modeling ensures that the recommended system is well designed, meets user ends, needs, and integrates seamlessly with the existing e-commerce platform. Thank you.